Hello dear students, welcome again to our chemistry class. Today we are starting unit number 5, and that is the periodic table of chemical elements. The first lesson is the historical background of the periodic table. In this lesson we will discuss how different scientists tried to classify chemical elements in a coherent order. And this lesson will be divided into two parts, and the first part will be the early attempts of classifying elements and Mendeleev's periodic table, and the second part will be discussed later after this lesson. Here is the periodic table we are talking about. You know it very well. And before we go further, let us have a look at the key questions one can ask himself or herself about the periodic table. What is the periodic table? What information does the periodic table provide? How can one use the periodic table to predict the properties of the elements? These three questions will all be answered in this unit. Objectives. At the end of this lesson, you should be able to describe how various scientists tried to classify chemical elements, explain the original periodic law, describe how Dmitry Ivanovich Mendeleev classified chemical elements, explain the modern periodic law, and describe the various classes of elements in the modern periodic table. Periodic table. The development of the periodic table brought a system of order to what was otherwise a collection of thousands of pieces of information. With a lot of chemical elements, so many information were scattered. The information was not something like which has a coherent order. So many information, or a lot of information, that could be provided from those elements, the knowledge of the different properties of those elements, was not in order. So it was necessary to have a particular order for that element to help in the understanding of the different properties, the similarities of elements, and the differences of those elements. When we say the similarities, it can infer the reactivity of those elements, if they react in the same way, the physical properties, if they have different boiling points, different melting points, different electrical conductivity. So it was necessary to make a classification so that all of that information can be gathered in something which is considered as a whole. The periodic table is a milestone, or we can consider it as a mark in the development of modern chemistry. As the periodic table was developed, then it was like the beginning of modern chemistry. So it is a very important event, the creation of this periodic table in the history of chemistry. It not only brought order to the elements, but it also enabled scientists to predict the existence of elements that had not been discovered yet. So when we talk about the classification of elements, here you should always remember that the scientists tried to classify elements, but then not all elements. Of course, they were trying to classify elements which were known by that time. But after that, they were able to predict the properties and the behaviors of some elements which were not discovered yet. And what they predicted their predictions were proven true when those elements were discovered later. Now, the early attempts to classify elements. It started with a scientist, a German scientist, called Dobereiner, and he tried to classify elements in triads, in groups of three. And he classified elements in sets of three elements that have similar properties. He found that the properties of the middle element were approximately an average of the other two elements in the triad. Here we have the example. We have the example of lithium, sodium, and potassium. You can see that if you take the mass of potassium and you add it to the mass of lithium, you find that it is twice the mass of sodium. Just as what we said, he found that the properties of the middle element were approximately an average of the other two elements in the triad. So here we have the example of sodium having a mass which is a half of the sum of the masses of lithium and potassium. It is the same even in group 2 for calcium, strontium, and barium, and even in the group of halogens when we consider chlorine, bromine, and iodine. And this doesn't only happen to the masses, it also happens with the density. Now the Dobereiner's triads explained. Here we have the examples. You can see the atomic mass. You can see here we have the atomic masses. We have the average of the atomic masses. You can see that the average is close to that one of bromine, which is in the middle of the triad. And here for strontium, it is almost equal to the average, which is also in strontium, which is also in the middle of the triad. And even the densities, you can see it is so close, so close. Note, in each case, the numerical values for the atomic mass and density of the middle element are close to the averages of the other two elements. Newland's octaves. Newland is another scientist who classified elements in octaves in sets of 8 elements, just like how he tried to compare elements like a set of musical notes. A set of 8 successive musical notes is called an octave. And then Newland compared the 8 elements in which the first element has similar properties to the 8th element and so on to the 8th element. He compared that classification to the musical note in music. He observed that when classified according to atomic mass, similar properties appeared to repeat for about every 8th element. We said that. And he attempted to correlate the properties of elements with musical scales. The octave, a set of 8 successive musical notes. And in the end, his work was acknowledged and he received an award in 1887 for the discovery of periodicity, the recurring of similar elements at regular intervals when they are classified according to the increasing atomic mass. Now, Newland's octaves. The Newland's idea of octaves applied to only a limited number of known elements, and he tried to apply this principle to the known elements, about 60 at that time, but however, they didn't all neatly fit this type of pattern. Highly reactive metals, for example, such as lithium, sodium, potassium, rubidium, and cesium, became grouped with very unreactive metals such as silver and copper. And for this reason, the classification was rejected. You can see how he tried to classify the elements. We have lithium, we have hydrogen, carbon, oxygen, nitrogen. This is how we tried to classify the elements. And his classification was rejected because it didn't work for all the elements, but his work was awarded because of the discovery of the periodicity, and we will explain this periodicity in the next lessons. Dmitry Mendeleev. You can see the man Dmitry Mendeleev here, and this part of chemistry is more historical than scientific. And Dmitry Mendeleev is a Russian chemist who classified chemical elements in a coherent order, and he is considered to be the father of the periodic table we use today. Dmitry Mendeleev is credited with creating the modern periodic table of the elements, and he gets the credit because he not only arranged the atoms, but he also made predictions. Some of the elements which were not known, which had not been discovered yet by that time, were predicted that they exist or they may be existing, but they have not been discovered yet. And some of their properties were predicted, and it was found that the predictions were quite true, accurate. And his predictions were later shown to be quite accurate. Mendeleev's periodic table. Mendeleev organized all the elements into one comprehensive table, all the elements which were known by that time, and the elements were arranged in order of increasing mass. And here will come the original periodic law. It is said that when elements are arranged in the order of increasing mass, elements with similar properties will be placed in the same row, and when they are classified according to an increase of atomic mass, there is a certain periodicity of the properties. So it means that atoms which have, or elements which have similar properties would come at regular intervals in the periodic table. For example, if you classify elements according to the increasing atomic mass, you find that sodium will be in the same group as lithium, as potassium, the elements which have the same chemical properties, the reactivity and physical properties somehow. It is the same for group 7, for example. Chlorine comes in the same group as fluorine, as bromine, those elements which have the same chemical elements. So that was the original periodic law, saying that when you arrange them in increasing mass, you find that there is a regular pattern of properties. The elements which have similar properties come at regular intervals, and for that reason they get classified or placed in the same group. The earliest version of Mendeleev's periodic table is shown here. You can see here we have the elements. This is fluorine, this is oxygen, this is nitrogen, carbon, boron, and this is beryllium. We have other elements here, and here there is something. You can see how it has been crossing out some of the elements if they are not fitting, and this is something very interesting. It is very interesting how it shows how everyone can make mistakes. We can all make mistakes, but with determination and commitment we can all make it, as long as we do not give up. It's very clear. Someone who is very known for an achievement like the creation of a periodic table, he could also make mistakes. You can see how many times he crossed out something he had written. So never give up. Everything is possible. You can make it as long as you have commitment and determination. Here we have Mendeleev's periodic table, and you can see the red color here. The red color here, you can see there is the atomic mass or the mass number, but there is no element. This was the empty spaces. The empty spaces you are seeing here, these were some spaces where he didn't find elements to fit in those spaces. And for some of the empty spaces, he tried to predict the properties of those elements which were not discovered. And here he tried to give the predicted atomic mass of the elements which were missing. Mendeleev left some blank spaces in his periodic table because the elements were not discovered. And at the time the elements gallium and germanium were not known, at that time they were not known. The spaces we have here, this space is for gallium and this one is for germanium. And he predicted their discovery and estimated their properties. And what is very interesting is that when they were discovered, the properties he predicted were found to be accurate. Germanium was called germanium because it was discovered in Germany. Now let us go to the exercise to end this part of our first lesson. Describe the classification of the Dobereiner and that of Newland. Which property of elements did Mendeleev consider when classifying elements?